So let's going to let's talk about the age-adjusted mortality rate. This is the last class for doing this epidemiological calculation. So no more epidemiological calculation after this. So this is the last one. Okay, yeah. So let's talk about this. Here, Oklahoma City and Tulsa, two different cities. Look at the death rate for all age groups. Which of the city is a higher risk of dying from disease, according to this data? Huh?
70 plus.
Which one is a higher risk of death rate for these between these Oklahoma City and Tulsa? Tulsa, 126 death rate. So you guys actually see, 126 versus 96. That's why Tulsa. Yeah, it's correct. But mortality rate, death rate, we need to consider these age populations, distribution of age group. Because as you know, as you're getting older, the chance to die is getting increased, right? Due to the aging process. So you guys actually take the physiology of aging class, right? What did you guys learn from that class? Physiology of aging.
As you get older, you're more susceptible to disease.
Yes, our like kind of body functions are getting decreased, so your chance to die increase as getting older. It's an aging process, right? Normal aging process. So when it comes to death rate, we need to consider age population. Look at the age population distribution between two. What is the difference, Tulsa and Oklahoma City? What kind of pattern did you guys find? Same populations, right? Same total population, but what kind of patterns did you guys find in this table?
Also has an older population.
Yes. Tulsa has more older population, this group, more than 70 years right now, right? Yeah. So that's why Tulsa probably higher death rate because Tulsa has more older adults, right? So that influence on this death rate. So that's why you think, Tulsa is the higher risk of dying from all these. It's correct? Possibly, but we might wonder if these two cities population distribution is the same, how about the death rate? It's going to be same or different? Probably in this point, at this moment, we cannot say, right? So we need to get some kind of a death rate. So I mean, total population same, but as we mentioned, age is the one of the important factor that we need to consider in terms of a death rate, right? But the populations, the age group population distributions are actually different, right? So Tulsa is more older others, so that's why higher death rate compared to Oklahoma City, right? Yeah. So age adjusted mortality rate is actually allows us to compare these two cities. If the age groups population distribution is the same. So make the same age distributions, and then we actually compare the death rate, and then we can make the conclusions that which one is the higher risk. Okay, so in these conclusions, actually probably there is some errors because the age distribution is different. So we're going to do calculate the age-adjusted mortality rate. Okay, yeah. So let's do that this once. Okay. So for more accurate comparison, it would need to control for the effects of differences in population age distributions. Okay, yeah. So I gave you worksheet. I gave you worksheet. And look at the table. What information we have right now? Yeah, population and number of deaths for each city, right? Yeah. So to get the age-adjusted mortality rate, we need to have three more informations. Age standard population, and then mortality rate, and then expected number of deaths applied from the standard populations. So let's work together to get this standard population first, okay? Standard population for the same age distribution. So as you can see, 30 to 49, 50, 500,000 Oklahoma City, and 300,000 in Tulsa, right? So we need to make these different age distributions make the same. How we can make the same? Just adding together, okay? So just adding together get the standard population. So what is the age 30 to 49 standard population should be? Just adding together both cities. Yes, 800,000. And then get the next age group 50 to 69. What is the standard population? 700,000. How about the 70 years old? 300,000. And then total standard populations? 1 million? Yes, 800,000. Very good. So we got this, right? Select a standard population, population summing up both groups populations, right? Yeah. So did you get the standard populations, right? Yeah. And then next thing is we need to get mortality rate, death rate. Each group's death rate. Age specific death rate for each city. The next thing is to getting mortality rate from original population using original populations, okay? So we need to get fill in the blank for this mortality rate here. Mortality rate here. How can we get this one? Okay, Oklahoma City age 30 to 49. What is the death rate? How we can get it?
Would we do 60 over average, I think?
Yes, and times 100,000. Yes, good. How about this? The next age group, 396 over and 300,000 and times 100,000 like this. So using original population, we can get the death rate. We already did last week, right? This one. Yeah, it can be 60 over times the constant. Yes. So I put the answer there, so you can check it out there. Yes. Yeah, you can check it out. That's good. You put that one. The sum of the total population. Each population. 500,000. Good. Good, yes. Maybe back there, one, good. 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 Yeah. Good. 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 Standard population is summing of both cities population. So 1,800,000 the total public population. And then we get the right? Yeah. Okay. So we have one more step, right? So we got the standard population, and then we also got the death rate, right? Mortality rate, yeah. So we already did the standard population and mortality rate. And then the last things that we need to do is to get the expected deaths applied from the standard population. So we need to calculate the number of expected deaths if the standard populations apply to these populations, each cities, right? So Oklahoma City and Tulsa, age population different, right? So that's why we make the standard populations, because we want to make the same population, age populations, right? And then we need to get the expected number of deaths applied from the standard populations. So how we can get the number expected deaths is very simple. Standard populations time death rate. Standard populations times death rate. So we got 96 for Oklahoma City, 32, 49. Does it make sense? How about this? 1700. Okay, and then divided by these constants. So that's why we got the 96. Okay, so simply standard population times death rate, and then divided by the constant, which is the 100,000 right now. So that's why we got 96 for number of expected deaths. Okay, yeah. So we can actually out this one. So 8 times 12 is a 96. Simply, math calculations, right? So 7 times 132 because we divide by the 100,000 or something like that, right? Yeah. Like this. So let me check and figure how you can get it. Okay. Okay. Standard population summing of both series. Yeah. Yes. But here's 100,000, 800,000. So we divide by this first is 8 flat, right? 8 times. Okay. Okay, I will talk to you about this one later. Adding these together and then compare with this one. Same or not? Same. So 1,728 is we adding this. Different. Which one? Okay. Yes. Adding these threes equals to 1,750. I will talk about this one, but I think this one total number.
This one of these.
Yes, but the numbers in 1,750. I will explain that one.
I don't want to buy these in the market.
No, actually adding just.
Okay.
So there are some. Yes. If we leave calculate, this one is 1,007. Yeah. Why? This one's not of the balance. And this end of the combination. I will explain. Think of this. Adding these three things, thinking focus on this. But you calculate by this one. Think of this one. You should be close to that. Yeah. Think about this. Adding these two things should be equals to this, but this 1,780 was not correct. The same. Think about this. Adding these three things should be equals to the. You are saying adding these three things should be equals to this, but 1,780 is not correct. Yeah. Take it out there. Death rate. Death rate. Times 7 times 132. Not 300. Yes, I will explain this one. Not a 1,700.
Yeah, that's what I have.
Yeah, it's not correct. Yes. We might need to think about this one. It should be equals to this. Yeah. Okay. I think most of you guys actually did a great job. So let's look at it here. If we calculate this one, total number of expected deaths by calculating from all ages, you got 1,700 or something like that. Why is this different from adding these three things? If you adding these three things, you might get 2,000 something like that, right? Why they are different? If we calculate the total number of expected deaths by like kind of standard population 1 million times death rate and then divided by 100,000, 1,728. But why it should be equals to this, but not this? What happened? Okay, go back to the first. Look at the table. Total population same or not? Same, right? Each city's total population same, right? So that's why that number of expected deaths just to reflect that total populations. But we want to look at it different ages distributions. That age different age distributions is the same. What is the death rate? So that's why. So this number reflects the standard populations. Okay, then we to make the same. So that's why when we get the total number of expected deaths, we should summing up these three things to be here. Okay, rather than just to multiply calculating these total populations. Okay, so you can get the total number of expected deaths by summing up all the expected deaths from all age groups. Do not simply calculate by using the total standard populations. Okay, so this is not 1,728. So actually 2,238 and Tulsa 1,830. Okay, so there is one more columns, right? So calculate the last one, adjusted mortality rate. So total number of expected deaths, we got this one, right? 2,238 over total standard populations and times constant. And turns out total number of expected deaths 1,830 over total standard population 1,800,000 and times 100,000. So we got age adjusted mortality rate. So total number of expected deaths over total standard population and times K, that is the age adjusted mortality rate. So Oklahoma City 124 per 100,000, and then Tulsa 101 per 100,000. Okay? So let's see. The crude crude mortality rate, the Tulsa is higher, 126. But as you can see, age adjusted mortalities, Oklahoma City is higher than Tulsa, actually. So which one is the accurate data? In terms of death rate? Which one is the more accurate one?
Just.
Adjusted one. So we probably, Oklahoma City is a higher death rate from all these, right? Because we have to consider ages distributions in the population, right? Yeah. Okay. So I have a couple